Okay, so the next example that we have here is given. Again, we're going to do the same thing where we highlight the important things that we would need. Okay, so here it is given that the object is 4 centimeter in size. Okay, which means this is what? H. You can also do this, like you write, you highlight whatever is important and then you write the symbol for what you have highlighted. You should do that so that you can write them easily when you are writing the given in the solution. Okay, it is placed 25 centimeter in front of a concave mirror. So this is the most important part, that it's a concave mirror. So 25 centimeter in So 25 centimeter in front of a concave mirror. That means 25 centimeter is what? Your U. We would add the signs later when we write it in the given part. Then it is given focal length as 15. So this means small f is 15. At what distance from the mirror should a screen be placed in order to obtain a sharp image? So when it says that where should the screen be placed, that's just another way of saying where the image will be formed. So basically, this should give you an idea. What did I say? That whenever an object can be captured on a screen, that means that it is real. And whenever it's real, what is it? What is the combination of words that we use? Real and inverted. So that should give you an idea that the image would be formed real and inverted. So you should be able to cross check, like when you get the final answer, when we calculate the magnification, then what should M be? Should M be a plus in a positive number or a negative number? It's real and inverted. So M should be a negative number, right? So you can just quickly, if the question is not asking for it, even then you can just quickly calculate M and see if it's coming out to be a negative number. So you can just know ki, okay, what we thought initially was correct. So these are some little cross checks that you can do while you're doing the question so that you're confident that you have done the question correctly. Okay, now let's move on. So we have to find out basically V, and we have to find the nature and the size of the image. Okay, great. So let's start the answer. So what do we do? Always the first thing that we do is we write what is given to us. So what all is given to us? We are given that the object is 4 centimeter in height. Now imagine, how is the object kept? Is the object kept upright like this, or is the object kept inverted? So what would be the sign of H? Would it be positive or would it be negative? Think about it. All distances above the principal axis, like the y-axis, are positive and below are negative. So the first thing that we know we are going to write here is H is equal to 4 centimeter. This we know. And what is the sign we are going to put here? Plus. Great. So I'm going to remove this now. We know H is plus 4 centimeter. What is the next thing? We are given that an object is placed 20 centimeter in front of a concave mirror. So I'm going to again do that thing where I draw a figure in rough. Okay, just for our reference. So it is a concave mirror. So we know concave mirror looks like this. Great. Then our object is placed somewhere here. Okay, this is our AB. So the next thing now we can do is now we can start thinking that what is the position of this object with respect to that table that we had drawn. You remember that table and the ray diagrams that we had done at infinity, beyond C, at C, between F and C, then at F, and then between F and P. So think about this. We are given that this object is placed 25 centimeter in front of the concave mirror. So that means this U is this distance between the pole and the object is U is equal to 25. I have not put the sign here right now. Keep this in mind. I will put the sign when we write it in the fair place where we are writing the given. Okay. So U is 25 centimeter in front of a concave mirror of focal length 15. Now think about this. The focal length is also, the focus is also on the left hand side and it is 15 centimeters from the pole. So would it come to the right of the object or would it come to the left of the object? Think, if this is 25 centimeter, this point here is 25 centimeter. Would 15 centimeter lie here? Okay, I'm making this minus 25, okay, because not to get us confused because it's on the left side of the pole. So if this is 25, would 15 be here or here, somewhere here? Think about it. On the number line, if 0 is here, this is minus 25. Would minus 15 be somewhere here or somewhere here? It would be before, right? 0, then the smaller number and then the bigger number, right? So I'm going to remove this now, and we're going to write that our focus lies somewhere here. And this is our focal length F. Now, what is the sign of the focal length? It's also on the left hand side of the pole. According to the Cartesian sign convention, it is negative. So we write minus 15 centimeter is the focal length. Okay. So now I'm going to write it here officially. We are going to write what is the next thing given to us? U. This is the object distance. So you have to write it full. Yeah, you have to write here object height, and then in the bracket you write this. Then you write here object distance bracket U, and then you write it. So you have to write the full sentence here. I am writing it in short form. Okay. So here you put the sign. What is the sign? Negative. The negative sign with what is the distance? It is 25 centimeter. Second thing, what is given to us? F. What was F? 15 to the left. So it's minus 15 centimeter. What do we have to find? We have to find V. Again, we don't put the negative or positive sign here in the V. We calculate it and then we automatically get the sign of V. Okay. Now, before I solve this numerically, let's just think back. If this is our F, this point is our F, and 15 centimeter is the distance between F and P, then where does the radius of curvature lie? So distance between focus and pole is 15 centimeter. Then what is the distance between focus and center of curvature? It is the same as the focus and pole distance, right? Because the center of curvature and the pole, what is the distance between the pole and center of curvature called? It is called the radius of curvature, and the focus lies exactly in the middle of the radius of curvature. So if our focus is 15 centimeters from the pole, where would our C be? Our center of curvature be? It would be 30 centimeters, right? The double of 15 basically. So it would obviously lie to the left side of 25. So this pole is our radius of curvature, which is 30 centimeter, minus 30 centimeter. Now, I want you to think back to the ray diagrams that we had drawn. Where is the object placed? At infinity, beyond C, where is it placed? It is between C and F, right? Now think back to it. Where is the image formed when the object is placed between C and F? Do you remember where it is supposed to be placed? Sorry. So do you remember where the object is formed? Where the image is formed when the object is placed between C and F? Think about it. It is formed, the image is formed beyond C. Okay. So now we're just going to keep it in mind that the object, from our previous knowledge, that the image is formed beyond C, and from our previous knowledge we know that it is going to be enlarged. If you don't remember this, then you have not revised the previous chapters. So go back to those videos, revise your concept, brush them up, then come and attempt this question and it will make sense to you. Okay, those who have studied, I know you can understand what I'm trying to say. Okay, now we'll solve it numerically. So we know using the formula, we are going to use the formula 1 upon V plus 1 upon U is equal to 1 upon F. Okay, now we are going to put the values we know. So we know 1 upon V. We are going to take 1 upon U to the RHS side. So it becomes 1 upon F minus 1 upon U. I am going to skip that step. You can write it if you want. So 1 upon minus 15. Yes, because it is negative. Minus 1 upon, what is U? Minus 25. So what does it become? Here it becomes 1 upon V is equal to minus 50, 1 upon 15 plus, because this minus and this minus, they combine and become plus. So plus 1 upon 25. This is our 1 upon V. Now we're going to solve this. And what do we get? We take the LCM of 15 and 25. Try and calculate it. I'll give you some time. Just pause the video and go calculate the 15 and 25 LCM. So once you've calculated it, it comes out to be 75. So 15 multiplied by what is 75? Multiplied by 5 is 75, plus 25 multiplied by what is 75? Multiplied by 3 is 75. Okay, so this gives us, what does it give us? 1 upon V is equal to minus 2 upon 75. Now we just have to invert it to get V, which is 75 by 2. What is 75 by 2? 2, 3 minus, first minus, then 2 3s are 6. 1, 7, 14.5 centimeters. Okay. So this is the distance. Now I'm not writing the whole sentence. You will write it yourself, that you will say that the screen should be placed 37.5 centimeters to the left of the mirror or to the left of the pole for a sharp image to be formed. Okay, that is what you are going to write. Now the next part, we've found where the screen should be placed. Now we have to find the nature and size. Now again, every time you hear nature and size of the image, immediately you should think magnification, because magnification tells you everything. So we write the formula for magnification here. H dash, which is the image height, upon H, which is the object height, is equal to minus V by U. Now, what all do we know here? We know V, we just calculated it. U was given to us and the object height was given to us, right? So we can calculate this H dash, which is what? The height of the image or size of the image. So therefore, H dash is equal to, I am taking H to the RHS. So it is minus V into H upon U. Now we put all the signs here. This negative sign right here is the negative sign of the formula. Keep that in mind. This is not the negative sign of the V. We are yet to put the negative sign of V. Okay. So here we put the value of V first, which is minus 37.5. Then we put the value of H that is given to us, which is plus 4. Then here we put the value of U that is given to us, which is, what was it? Minus 25. Okay. Now, so you can see that this minus and this minus, they combine to become plus, and then we still have this minus from the 25 left. So this means the whole number is going to be negative, right? So when you calculate this, this comes out to be, you're going to calculate this yourself. It comes out to be 6 centimeter, but with a minus sign, right? Now, we are first going to look at the number part of it, and then we are going to look at the sign part of it, and then we are going to see what it all means. Okay. So first we look at the number part of it. Now, what was the original object height that was given to us? It was 4 centimeters. And the image height, what is it? 6 centimeters. So is the image bigger than the object, or is it smaller than the object, or is the same size? It is clearly bigger than the object. Now we can relate it back to what we had thought initially. You remember when we had looked at the ray diagram that we have drawn in rough there, we had said, okay, the object is placed between C and F. So because we have done ray diagrams before, we know that the image will be formed beyond C and it will be enlarged. And here what we had initially thought is basically confirmed, that yes, the image we formed is bigger than the size of the object. Next, now we're going to see what this negative sign means. This negative sign means that the image is formed in the downward direction, right? Do you remember how we said we measure distances perpendicular to the principal axis? Here, look at the diagram I've drawn, AB, perpendicular. So our image would be somewhere here and enlarged, A dash, B dash. So is it going to be measured in the upward direction, the image, or in the downward direction? The image is going to be measured in the downward direction, right? So what is the sign going to be? Is it going to be positive or is it going to be negative? It is going to be negative, and that is exactly what you have got here. At H dash is equal to minus 6 centimeters. Okay. So now you have the position at which the screen should be placed, which is the V. You have the nature, you write, because you just write this statement that this negative sign suggests that the image formed is real and inverted. Okay, so you write this, the whole sentence. I'm just writing real inverted, and the size of the image is what you had to find. So you write that the image size, you write the whole sentence. The size of the image was found to be 6 centimeters in the downward direction, or you straight away write minus 6 centimeters. Okay, so that is this question solved for you. Okay, moving on. Let us see the next. Okay, let us see the next question that is given to us. So we are given, find the focal length of a convex mirror whose radius of curvature is 32 centimeters. Now, even for the smallest of answers, you should just write whatever is given to you, because it makes your answer very methodical. Okay, so we are given radius of curvature is 32 centimeters. What is the sign that is going to come here? Again, whenever you have a doubt like this, just quickly draw the diagram in rough. Okay, so here is your convex mirror, somewhere here is your focus, and somewhere here is your center of curvature. This is your pole. So what is the radius of curvature? Is the PF distance the radius of curvature, or is the FC distance the radius of curvature, or is the PC distance? Yes, it is the PC distance, that is the radius of curvature. So now, where is the radius of curvature measured towards? Is it measured towards the left side of the pole, or is it measured towards the right side of the pole? Yes, it's measured towards the right side of the pole. So, like in a number line, all numbers to the right side of 0 are positive. So, as the radius of curvature is measured towards the right side of the pole, that's why it's going to be positive. So, our R here is positive 32 centimeters. Okay, so here we give you a positive sign. Okay. So, what is the relation that you have been using for so long? The radius is equal to how many times the focal length? Come on, you should all know this by now. The radius is equal to 2 times the focal length. This is a very important formula. Okay, even if you don't use it in a question directly like this, it would be used in some small part of a large question as well. They'll just give you the radius of curvature if they don't give you the focal length directly. Okay, so what is our focal length? It is radius of curvature divided by 2, which is 32 by 2, which is 3, 2 ones are 3 and 16, right? So our focal length is 16 centimeters. Okay, that is all we had to find, and our focal length comes out positive, so we know that we have done it correctly. Okay, moving on to the next question now. So let's read the question. The question says a concave mirror produces 3 times magnified or enlarged real image of an object placed 10 centimeter in front of it. So we have to find where the image is located. So what all is given? It is a concave mirror that is given to us. 3 times magnification. So we know that magnification is produced 3 times. But look at this part of a real image is formed. What does a real image mean? What are the two things with real? What are the two words that are always used? Real and inverted. So if an inverted image is formed, which means the image is like hanging off the ceiling, right? So would the distance of the image be measured in the negative direction, or would it be measured in the positive direction? It would be measured in the negative direction, right? So what would the sign of this magnification be? You remember when I told you there are so many things that magnification can tell you? One of that was how the image is formed. Is it real and inverted, or is it virtual and erect? So negative means that the image is formed in the downward direction, which means it is inverted, and because it's inverted, it's real, and that is what is given to you. So we'll give a negative sign here. Okay, so we're given m is -3. A real image is formed of the object placed 10 centimeter, which means u is 10 centimeter. What is the sign? We will see. So we have to find the image. We have to find v. Again, simple procedure that we follow. Always write, when you're doing the answer, the given things. So we're given it's a concave mirror. Just always write this heading, like which mirror is given to you. Just always write it as a heading. Makes it much easier for you. Okay. So we are given that m is -3. We're not given this. We basically used our previous concepts and calculated basically what the m is going to be. So 3 times was given to us. The negative sign, we used our logic and what we know from previous classes, how this negative sign came here. Okay. So m is -3 and we are given an object is placed 10 centimeters. So this is your concave mirror. Again, just draw it in rough. Here is your focus somewhere here. Somewhere here is your center of curvature. So we don't know where it is actually placed, but again, think about what you learned. When is a concave mirror giving you an enlarged image? We just did it a few minutes back. It gives you an enlarged image when the object is placed between F and C, right? So if this is your AB, if this is your image, then where would your, if this is your object, then where would your image be formed? Somewhere here. A dash, B dash, right? Somewhere here. So we are given that the object is placed at 10 centimeter. Now 10 in the negative direction or 10 in the positive direction? Look at the diagram from the pole or the 0. It is in the negative direction. So it would be a -10. So right here we write U is nothing but -10 centimeters. Okay. Next that we have to find is V. So we know from the magnification formula that M is nothing but H dash, which is the height of the image, upon H, which is the height of the object, or another way to write it is -V by U. Again, students, one thing that you have to always remember is this V, this minus sign is not actually the minus sign of this V. This is the minus sign of the formula. So when you put in the value of V, you have to put in a minus sign if the V has a minus sign. Right now we are finding out V, so we don't know the sign of V, but when you know the sign of V, you put it here. You don't think ki, oh, V is negative, but we already have a negative here, so we don't put the negative sign of V. No, this negative that is written here is the formula ka negative. So you don't have to take it into account in case you are writing your V ka sign. You have to write your V sign here. Okay, so moving on. So what we have is, what do we have here? What is given to us? We know U. We have to find V. And what else do we know? We know the magnification. So basically this part of the formula is not going to be used here. But why do I always write it like this? So that you don't forget that all these three things are equal to each other. Sometimes if you don't write the M is equal to H dash upon H for a long time, you might just forget. And then you might not remember it when you actually need it. So try to make this a habit to always write M is equal to H dash upon H is equal to -V by U, even if the H dash part is not going to get used or the VU part is not going to get used, write it whole. Okay. So in the next step, we can write that we know that M is equal to -V by U. We have taken out the part that we need. So what do we need to find? We need to find the V. So we take the U to this side and we take the negative sign to this side. So basically our V is minus of M into U is equal to V. So what is M given to us? This minus sign says here because this is a formula minus sign. Then what is M given to us as? M we calculated as -3. And what is U given to us as? It is given as -10. So this is our V. Then what does V come out to be? This minus and minus, they combine to become a plus and it looks like a smiley, and this minus sign still stays here. So it is a minus sign of 3 into 10 is equal to V. So therefore V is equal to -30 centimeter. So there we have it. We wanted to see where the image will be placed, and this is where the image is going to be placed. Okay. So students, in this lecture, we learned about the mirror magnification formula and how we apply it to numericals. Okay. So what is very important for you to remember now is how we use the sign convention. How do we determine which direction is positive and which direction is negative? Extremely important for you to remember. And then using it in numericals, always remembering to make the small rough diagram so that you have an idea of it. Then definitely brushing up on the ray diagram that we did, because you can see here how we can just quickly cross check if the answer we have got is correct or wrong. Okay, so these are the things that you have to keep in mind. Practice some more numericals from your book, and come prepared for the next class. We are going to start a refraction of light. Okay, I hope you enjoyed this lecture, students. Thank you and take care.